Okay, I wanted to finish up section 11.5 now, and we are talking about function composition. And okay, if I just go back to here's the definition for the composite function. F composed g of x is defined to be f of g of x. Whatever function is after the open circle, you're going to plug that into the one that's before the open circle. Okay, so here I'm plugging g into f. Here I'm plugging f into g. Okay, we looked at some applications. I mentioned here that when you work with unit conversions, that to me is the application of function composition. There's other applications, but this is a big application. So we, I think we did problem 36 and problem 37 here. We talk about domain next. To find the domain of the composite function f composed g, use the steps that are below, 3 steps. Step 1, find the domain of g. Okay, and then step 2, compute the composite function f composed g of x and simplify. Determine the values of x. The domain of f composed g would be the combined set from steps 1 and 2. All right, so let's take a look at problem 38 here. I've got two functions, f of x and g of x, and I want to compute f composed g of x. Well, that means I got to find f of g of x. G of x is 2x minus 9. So everywhere that I see an x in f, there are 2 of them, I need to replace those with 2x minus 9. Okay, and so I've done that then on the next line here. Replace x with 2x minus 9, and then simplify. Distribute 5, you get 10x minus 45 minus 8 is minus 53. And then down under, we're looking at 6x minus 27 plus 10 is minus 17. This would be as simplified as we can get it. Okay, so that'd be my answer. That's the composite function. And again, like any other function, there's input values and output values. So like if I wanted to plug 3 into the composite function, I could recalculate it again like I did with x. F composed g of 3 means that I want to find f of g of 3, just like what I was doing here when it was x. G of 3 is negative 3. Okay, so in this problem, we are just supposed to find f of negative 3. If you plug in negative 3 into f, negative 15 minus 8 is negative 23 in the numerator. Negative 9 plus 10 is 1 in the denominator. Negative 23 over 1 is negative 23. Okay, now you could also plug 3 directly into this formula that we've created. That would be fine. 10 times 3 is 30, minus 53 is negative 23. 6 times 3 is 18, minus 17 is 1. You still get negative 23 as the result. And of course, like any other formula that you'd be building, it'd probably make the most sense to be just plugging the number directly in the formula. Okay, otherwise why are you creating the formula if you're not going to use it, Part C, state the domain of f composed g. So step 1 is to find the domain of g. You see, g is being plugged into f. So we have to know the condition on g before we start plugging these numbers into f composed g. Like there may be a problem with, certain numbers and plugging them into g of x. Well, g of x is a linear function. The domain of any linear function is all real numbers. All right, so initially we're not throwing anything away. We can use any number that we want here for g of x. Step 2, we need to compute the composite function and simplify. All right, we've done that. That's what we have circled here. Determine the values of x. Well, I know I can't divide by 0, so let me just kind of do a side calculation here. I'm going to set the denominator equal to 0 and solve. And I get x equals 17.6. Now that's what I don't want. Okay, I can have any number except 17.6. Okay, because if x is 17.6, you get 0 in the denominator. That's no good. We know we can't divide by 0. Okay, so I was plugging 3 into the composite. I can plug in any number I want, just don't take this one here, 17/6. There's one more problem in this section that we'll look at. So problem 39, consider the functions f and g that are given there. Part A, compute the composite function f composed g of x. All right, so that means I got to plug g into f. Here's g of x, it's 3x plus 14. Everywhere that I see an x in f, there's only one. Replace that with 3x plus 14. And so I've done that. I'm looking at the square root of 3x plus 14 minus 2. 14 minus 2 is 12, right? So we got the square root of 3x plus 12. That'd be our answer. Okay, now what if I wanted to plug -1 into the composite function? Well, I can just plug that into my formula here. 3 times -1 is -3, plus 12 is 9, and the square root of 9 is 3. So 3 would be the output on that. Okay, how about what if I wanted to plug 2 in? 3 times 2 is 6, plus 12 is 18. Root 18 is going to break down using 9 and 2. Square root of 9 is 3, right? So 3 root 2, that would be the simplified form of the square root of 18. And of course simplify, as far as you can go, like any other problem that we've been doing. Part D, state the domain of the composite function. All right, so step 1 again, and that is to find the domain of g. Well, here's g of x. G of x is a linear function. The domain of any linear function is all real numbers. Okay, so again, I'm not initially throwing anything away here in step 1. Step 2 is to compute the composite function and simplify. We've done that. And then determine the values of x. Okay, so here's the composite function in simplified form. Determine the values of x. Well, I know I don't want an overall negative to be underneath the square root sign, right? I'm not doing anything with imaginary numbers. So let me just kind of set up a side calculation here. 3x plus 12. I don't want that to be negative, so I'll set that to be greater than or equal to 0. Solve for x. If you subtract 12 and then divide by 3, 3 is a positive, so you're not going to be flipping the sign. Remember, you only flip the sign if you multiply or divide by a negative. And so it looks like x has to be greater than or equal to -4. Okay, so anything that is -4 or bigger is going to be okay to use as an input. Here I was using -1, that's okay. 2 is okay, right? Any number as long as it's -4 or bigger is going to be okay. We don't want x to be less than -4. That's no good because then we'll have an overall negative underneath the square root sign. And again, we're not doing anything with imaginary numbers. Okay, it's all about the real numbers that we can use here. All right, so that's it for this section. Hopefully that's enough. The homework is on page 911. Be sure to look at the odd numbered problems listed there.